So here we're given that p is a negative number and s is positive. It's given s is greater than 0 and it's less than the absolute value of p. So we know that s is positive. And they're asking which of the following choices must also be a negative number. And we can right away rule out the first three choices because they all are some expression squared. So anything, it doesn't really matter whether s minus p, p minus s, or p plus s is positive. Once you square it, all three are positive. So the first three choices are out. We're really just left with p squared minus s squared and s squared minus p squared. Now if p is negative, one way to do this problem in a general way would be that absolute value of p is minus p, because p itself is negative, so minus p would be positive. So this inequality becomes minus p is greater than s. Now, both sides here are positive, even though this is minus p, because p itself is negative, it's positive. And we can square both sides because these two are positive. Usually can't do that if it's negative. And this becomes p squared is greater than s squared, which means that s squared minus p squared is negative. I subtracted p squared from both sides. So the correct answer is choice E. So this would be the direct way of doing it. The other choice would be to select numbers. So we know that p is negative and we need to satisfy that inequality. So if let's say s is 2, then I need to pick p something like minus 5, which certainly absolute value of minus 5 is 5, which is greater than 2. And then we can substitute the answers, and we know that the first three are out because we're squaring them. And D would become p squared minus s squared, which is 5 squared, well, actually minus 5 squared, minus 2 squared, which is 25, minus 4, which is 21. So that one isn't negative. And then E is 2 squared minus 5 squared, which is 4 minus 25 is negative 21. So we can also use actual values to show that E must be negative. So the correct answer to recap is E.